So there is a number num, okay, and this number can contain up to 10 raised to power 5 digits. And because it can contain up to 10 raised to power 5 digits, it cannot be represented in an integer or long, so it is being represented in a string, and these are the characteristics of strings which you can read on the board. So string will not contain leading zeros. It will not represent a negative number. It will represent a non-negative number for sure. And then there is one more thing. You can assume that, hey, it only contains digits. So it doesn't contain any random character like hash or ABCD, something like that. It only contains digits. So now you feel very much convinced that, yeah, it is going to represent a proper non-negative number once these three things have been said. Does that make sense to you guys? Yes or no? So our first input is this, and our second input is an integer k. So this is of type int, okay? Integer k. Now, let me write something. We are allowed to remove k digits. Okay, we are allowed to remove k digits from this number num. Okay, what we have to do is we have to return the smallest number formed by doing this. By this I mean to say this thing. Okay, so we are allowed to remove exactly k digits. After removing them, I should obtain a number that is smallest possible. That is what my target is. Is the question making sense? Just type in yes or no to understand that. Okay, so sorting allowed, that you think, should it be allowed or not? What do others feel? Is something like sorting going to be allowed over here when you read the nature of the question? No, right? Because when it says you are allowed to remove certain digits, after you have removed them, the relative position of other elements or other digits should remain the same. So let us take an example. Let's say you have been given 5140692. Let's say this is your num, and let's look at it very carefully now. So if you remove 4 and you remove 3, then your result should be 510692. Do you understand this? So relative position of the elements after removing whatever you have removed should be intact. Is this making sense to all? Yes or no? Right? So if this makes sense, do you now realize that why sorting is something which is not allowed over here? Because if you sort, then you would have forgotten about the relative positions of the numbers. Is that making sense to everyone? Yes or no? Before we just move ahead. Okay, guys, tell me one thing. The way we mentioned constraints for num, which is an input, should there be some constraints for this k according to you? Any constraints for k? If you feel it should be, then what it should be? Yeah, both of you are right, Nishant and Pradeep. Very good. So the constraint will be that k has to be smaller than or equals to the length of the string. The length of this string, it is num. Yeah. Because if there are 100 digits, you cannot remove more than 100 digits, right? So there will be one constraint on top of it. Cool. Now let me tell you one thing. Whatever your answer should be, it must not contain leading zeros. So my answer must not contain any leading zeros at all. So that you have to ensure while you solve this question. I'll take a quick and a very easy example for this question. So let's say your number is 352 and k is equals to 1. So who can tell me the answer for this case? 32. Okay. Yeah. So I believe all of you are saying 32. That should be right. We can even try it because it's very easy. So I have got 3 digits. So I can either remove 3. If I remove 3, I'll get 52. If I remove 5, I'll get 32. And if I remove 2, I'll get 35. And smallest is 32. So my output should be 32, which is being gotten by kicking this 5 out. Okay. I believe all of you got how this is the output. Let's move one step ahead and consider a bigger example and see if that somehow sends you some signal. So this time, this is our num and this is our k. K is still 1. Now tell me what will be the answer. Think, no need to rush through it, because when you rush, you might get a wrong answer. Think what you'd get. 132219, which you are getting by removing 4. Okay, good. Yeah, so I believe that's right. So in this case, your output is going to be 132219. You can try out all the other possible removals that you want to try out, and you will see that this will be the smallest number that you can obtain after removing exactly 1 digit from this number. Okay. Now that we have seen this example and now we know what output could be, we have considered a very small test case. We have considered case for k equals to 1. Let me ask you a very simple question. Some people, when they read this question, they immediately come up with sorting logic, and then later they realize it is not to be applied because of relative order needs to be intacted. Second kind of logic that I hear from people is they say that, hey, why not remove first k elements? Is that the right idea? Is that the right idea to remove first k elements from number? The answer is no. We have just seen the examples for that. This was the easiest example. The first number is 3. If you remove it, you will get 52, which is larger than 32, right? And now just think logically that why this idea is not right. If you come up with a logic to prove why this idea is not right, then you might start jumping into the path to the actual solution. Okay, guys, so think of it in this manner. Let's say there is a number which consists of n digits. Okay, listen to it very carefully. Okay, let's say there is a number which consists of n digits, and if you remove 1 digit from here, what will be the length of remainder? The length of the remainder will be n minus 1. It will be containing n minus 1 digits. Now, is it guaranteed that the result that you will get of n minus 1 digits, if it starts from the first thing, then only it will be smallest? Is it guaranteed? No. Similarly, if it starts from second thing, then only it will be smallest? No, it is not guaranteed. So no matter whether you remove 3 or you remove 5 or you remove 2, the result that you will get will be of 2 digits only. Now, out of these, which one is smaller is dependent upon the fact that this is starting with 3 and this is starting with 5. So there is no ordering at the level of these numbers. You do not know whether the first number will be smaller than this or this number will be smaller than this. So you can't just blindly remove some numbers. Okay, so I can say that, hey, this random logic is not going to work. Does that make sense? That why is that not a good idea? Yes or no? Yeah. Okay, so what are the different ideas that you guys have come up with? One of you is saying what we can do is start from the first position. If current element is greater than the next element, we will remove, but we have to consider about 0. That much is not sufficient. One of you is saying first big number k times this logic. First big number. You want to remove the first big number. What does that mean? It does not make a lot of sense, right? Because if, let's say, you have been given something like 549, something like this, and your k is equals to 1, and you are saying first big number. So that number word is not making sense to me. I believe you are trying to say first big digit. So first big digit over here is 9. If you remove 9, you will get 54. But I would have said that, hey, why you are removing 9? You remove 5, because if you remove 5, you would have gotten 49. So doing it greedily in this manner is not right. Okay, does that make sense? Yes or no? Okay, one of you has come up with a very good intuition. So Shivam is saying the number should be lexicographically smallest after removal. Very good. How many of you understand that? Just type in yes or no. Do you guys understand the meaning of lexicographically smallest or something? Okay. Not sure if you have gone through previous topics then. You should have. Okay. Yeah. So it makes more sense to come to a topic after visiting previous topics. Otherwise, these small things will be missing and pinching you. Okay, cool. So if I take a look over here, I can say that lexicographical order is nothing but it is dictionary based order. So if you say that 129 is let's say smaller than 134, it is because 1 matches, but here 2 and 3 do not match, and 3 is greater, so this is lexicographically greater. So whatever our result should be, that should be the lexicographically smallest result, and lexicographically comparison or normal comparison both are same. Okay. So how do I move about it? How do I solve this question? I need to remove some specific set of digits only. I can not just randomly remove anything. What we'll do is we'll consider another example where k is a little larger and see what happens. Yeah, can you give me the output for this case? 4, 3 and 2 will be removed. That way you get 1, 2, 1, 9, right? That is right. That is correct. Cool. So let us take a look. Here, if you guys remove 4, 3 and 2, you will get 1, 2, 1, 9. And this is probably the smallest thing over here. Okay, this is the smallest result that you can get. Now, enough of examples. We can start with some logic building over here. So let me ask you one simple question that is different from this actual question that we are solving here. So let us say you have been given a number n, which is 510462. And so this is your number, and I ask you one simple question. I want you to change any one digit. Just change any one digit to anything. But after you have done that, the result should be smallest. Do you understand? Change any one digit to anything. After you have done that, the result should be smallest. So you tell me, which digit will you change in this case? Yeah, Manoj, you are on the right track. Yeah. Yeah, you'd want to change 5, isn't it? You'd want to change 5. You'd want to change 5 to maybe smallest thing, which is 0, because if you change 5 to 0, you will get 10462. Okay. Similarly, if you would have wanted to change a number to change a digit to, let's say, 1, not 0, then you would have wanted to do that with this digit. That way you would have gotten this. Why? Logic is very simple. Because I know for sure that anything that starts with 1 and is of 6 digits will be smaller than anything that starts with 5 and is of 6 digits. So if, let's say, you had gone ahead and converted this into 1, you would have gotten something like this, which is going to be bigger than this, right? So what do we understand from here? We understand from here that we would want to make change at the highest place values. At the highest place values. The place value of this thing is higher. That is the reason you are trying to make change over there, right? So this is one greed that we understand. So if we want to remove something to get an overall smaller result, our intent will be to start removal from this end, not from the other end. Is that making a bit of sense? Just type in yes or no. Okay, great. So we can move ahead. So this is the first idea. Okay, now let's talk about this idea more. So if you take any example, in fact, the example that we had taken before, where our number num was 1432219 and k was 1. So what did you do over here? Which number did you remove? You removed this 4 because of this 3, right? So you removed this 4 because of this 3. So I can say that, hey, this 3, it kind of ate that 4, which was coming before it. And that way you got a result of 132219, right? Now, what is it which comes to your mind? Which kind of data structure will help you to pull the number backward in a very easy manner if something immediately after it is being removed? So think of it in this manner. Which kind of data structure will help you out with that? Okay, so let's say if I had a stack, and in that stack I had kept 1 and then 4, and now when I am at 3, and if I want to remove this 4, I can just remove it and put this 3 over here. Do you understand the point why I am talking about stack? Because using stack, we all know that, so you might have solved a parenthesis problem like this in stack. So you all know that you start with a stack. In that you first push this, and then you push this, and then you push this. Now when you see this, using this you pop this item and you automatically come over here. So it ate this much part, and now this much is reflected over here. So whenever such kind of use cases come up where using something you have to eat a lot of things that come immediately after it, stack is the data structure to go. So this hints about something like stack. Is that making sense? Just type in yes or no. Yeah. Okay, cool. Now what we'll do is we'll take one more example and then we'll be right on track. So let's say we have been given a number that looks like 2, 3, 4, 5, 6, 7. And let's say k is equals to 1. What should be your answer over here? Think and tell. Yeah, so all of you are trying to remove 7. One of you did not remove 7. One of you removed something else. I'm not sure why you did that. I think you should be removing 7 only. If you remove this 7, you will get 2, 3, 4, 5, 6. And let us talk about that. Now we'll logically understand why this 7 has been removed. Look at the board. So this is our initial number, 2, 3, 4, 5, 6, 7. Okay. So let's start from here. If you have to remove first number out of all the k numbers, would you want to remove this 2? Is it legitimate to remove this 2? If you remove this 2, you will get 3, 4, 5, 6, 7. Technically, you will get something which contains 5 digits and starts with 3. Now use your common sense and tell me, something that contains 5 digits and starts with 2 would have been better than this, would have been smaller than this. Don't you feel so? Yes or no? Right? So does it make sense to remove this 2? No, right? I'm not sure if others are able to understand this point. This is a very critical point. Is that making sense to everyone? Or do you guys want any repetition? Can we all have some responses before we move ahead? Don't worry about 0 and other cases. Okay, we'll come to that later. Is this particular example making sense? Yes or no from everyone? Why has this been done? Why I'm saying that 2 should not be removed? Okay. Similarly, think and tell me, should 3 be removed? Would you want to remove 3? So if you have got 2, 3, 4, 5, 6, 7, and if you remove 3, you will get something which will be looking like this. And this is a 5-digit number starting with 2, 4. 5-digit number starting with 2, 4 and 5-digit number starting with 2, 3. Which one would have been better? Tell me. 5-digit number starting with 2, 3 would have been better, would have been smaller. So it does not make sense to sacrifice this 3 if you have got something larger after it, right? Is that again making sense based on the same logic? So I would say that, hey, getting rid of 3 also does not make sense. Similarly, would you want to get rid of 4? Again, the answer will be no, because if you get rid of 4, you will get 2, 3, 5, 6, 7. And if you look at this 2, 3, 5, 6, 7, it is starting with 2, 3, 5. And something starting with 2, 3, 5 will be greater than something that would have started with 2, 3, 4. And now this logic can be extended on and on and on. Are you able to extend it on your own? Yes or no? Right? So this way, you can just go ahead. You can say that, hey, if you would have removed 5, you would have gotten 2, 3, 4, 6, 7. And again, this would not have been the right choice because this is something which starts with 2, 3, 4, 6. And something that starts with 2, 3, 4, 6 would be greater than something that would have started with 2, 3, 4, 5. And similarly, if you would have removed 6, you would have got 2, 3, 4, 5, 7. And I can say that, hey, something that starts with 2, 3, 4, 5, 6 would have been better than something that starts with 2, 3, 4, 5, 7. So as a final choice, you would just have removed the last number. You'd just have removed the last number. That is the best possibility which you have. Okay, because removing anything else would be foolish. because if you do not remove that, if you retain it, it would have been better. So what did we note here? We noted over here, do you see something peculiar about the sequence of digits in this number? If yes, then what is it? Anything peculiar about the sequence of digits? Yes, very good. The digits are all coming in sorted order. Sorted, or they are all coming in monotonic way, right? So if the digits are appearing in monotonic way and I have been given a value of k, does it make sense to directly remove the final k elements? So even if your k was 2, it would have made sense to remove last 2 elements. Is that making sense? Yes or no? Right? Because the first digit would have been this 7 to go away, and after that the next digit to go away would have been 6, if at all you are trying to minimize your result as much as possible. Cool. So what we understand from here is that if the order of digit is monotonic, then we avoid any kind of removal. We avoid any kind of removal, and we understood the logic behind that. We understood that anything starting with 2, 4 is going to be larger than anything that starts with 2, 3, and so on and on. Now, do you believe this idea is going to help you in any manner? Okay, so I believe that you guys must be learning stacks, and we realized that stack is the right data structure to use here. Have you already done some questions in stack where we used to maintain a monotonic stack, which was sorted from bottom till top? Anyone who can recall that? No, not in reverse. Others can't recall that. It's very good. Next smaller, next larger, next greater. Everywhere in almost all the questions of the stacks, in almost all the good questions of the stacks, we had seen that we were maintaining a monotonic stack, right? And why only stack? Why not an array? Because in stack, it is very easy to kick the elements from one end. Okay. Cool. So I believe it makes sense. So do you realize a bit that this is a question of similar category only? How many of you have realized it by now? So I'll take a specific example and try to demonstrate. Okay, let's take a look. So let's say we have been given a number and it is 1467932 and k is equals to 5. Can you remove the 5 digits from this number in a methodical way based on the intuition that we have learned so far? Okay, so almost all of you are able to guess the answer. That's good. But how do I do it methodically? How do I maintain a monotonic stack? And when do I kick out a number? How do I kick out a number? How these decisions are made? I'm interested in that. Let's talk about that, guys. Very simple, nothing very serious about it. So let us start with the first digit. The first digit is 1. Okay, the first digit is 1 and you are considering that first digit somewhere. Now let us move on to the next digit. Look at the board. This next digit 4 is greater than 1. Because this 4 is greater than 1, would you want to remove this 1 at the cost of that 4? Does that make sense? Yes or no? Would you want to remove that 1? Is that the right thing to do? The answer is no. It is not right thing to do. Why? Because you think on your own. If you remove this 1, it means you will get a result starting with 4. And if you retain this 1 and remove maybe something else, then you will get a result starting with 1. And anything starting with 1 is naturally smaller than anything starting with 4. So can I say that as long as I am getting the numbers which are progressive, which are monotonic, I'll not remove anything. I'll just considering them one after the other, one after the other, one after the other. Is that making sense? Yes or no? Right? Okay. So you realize that this 4 is greater than this 1. So you will simply consider this 4 here as it is. Now you come to this 6. Again, this 6 is greater than 4. So you will consider it as it is. Again, this 7 is greater. Consider it as it is. 9 is greater. Consider it as it is. Can you tell me what to do here at this point? You are at 3 and this 3 is not greater than this 9. So what do you want to do at this stage? Pop 9. Very good. But tell me, would you just want to pop 9 only, or would you want to pop a lot of things starting from 9? Yes. How many things would you want to pop? 4 things. Very good. So I can say that when I am at this 3, I can say it makes absolute sense to kick this thing out. Why? Because if I kick this thing out, I'll get a number which starts from this. And this is going to be definitely smaller than anything that could have started with 1, 4, 6, 7, 9. That is the basic idea. This remains the basic idea, lexicographic ordering. Why stack? Because it helps to pop very easily. And why monotonic? You understand that, because if it is monotonic, it does not make sense to pop. So at this stage, when you realize it, what you will do is you will just kick it out. So you have made one kick, and now you have 1, 4, 6, 7. Now the top of the stack, still it is greater than this 3. So you will continue to pop. So you will pop this thing also. So second removal has been made. Now this is what you have. Your top of the stack is 6 and current number is 3. This still is greater. So again you would pop. This is the third time you have popped. Now this is what you have. Okay. Still this thing is smaller than this. So again you will pop. This is the fourth pop that you have made. 5 pops you were allowed. I mean 5 removals you were allowed. And at this stage, what will you do? At this stage, will you pop this one because of this 3? Does that make sense? Or will you just push it? The answer is you will just push it. Do you realize that at any stage your stack is monotonic? So I have not drawn that stack in a bottom top manner. I am doing it horizontally only, but I believe you get it. At every stage it is monotonic, and this is how things happen, right? Okay, cool. So can you do the next set of iterations? From 3 you will move to 2, right? From 3 you will move to 2. When you come to 2, you realize that the topmost element is greater. Topmost element is greater. What will you do? Again you will pop. You will pop this 3. Okay, so this is the 5th pop that you have made, and now your stack looks like this. Now it is 1 which is smaller, so you will just push it. Okay, now you will come to this 1. Keep looking. This 1 is smaller than the top of the stack, so will you pop? How many of you believe you should pop here? No. Why we should not pop? Why we should not pop? Because I have already popped 5 items. So this is another thing to be kept in mind. Just don't blindly keep popping. Keep a track of the number of removals that you have done. And if you have already done k removals, then you should not do anything. Then you should simply push that element as it is. And that is the reason 121 would happen to be your answer. Does it make sense to everyone now? How many of you can connect the different concepts and intuitions that we have brought on from beginning? Okay, great. So I think, how many of you can implement it, by the way? Those of you who are at stack and have done at least 50-60% of the stack, I will expect you to implement it. So do you believe it can be coded by you all? Okay, great. So the implementation is going to be exactly same as next greater element or variants of next greater element. Okay, cool. Now I have one simple question for you. So when did you use to pop element from the stack? When did you use to pop? You popped when your current element, if I call this thing as current element. So if your current element was found to be smaller than the top element of stack, then only you used to pop from the stack, isn't it? Yes or no? Right? Okay, can I put an equality sign over here? Can I pop if my current element is equal to the top element of the stack? And don't give random answers. First think and then say yes or no. Okay, so many of you are saying no, and one of you is saying yes. I want others also to think on top of it. So those of you who are saying yes, what do you believe? Even if you write a code which says smaller than equal to rather than strictly smaller, then it will work exactly alike. Do you believe something like that? Ideally, it should not happen like that, isn't it? Okay, let us take a look to understand that. So let's say your number is 4473 and your k is equals to, for example, 1. Can you tell me your answer for this case? What is the expected output for this case? 443. Very good. You can just remove this 7, and if you remove this 7, you will get 443. Now, if I solve this question methodically, what will I do? So first I'll push this item in my stack, and now this is the current thing. Now you think and tell me, would you have wanted to pop this 4 because of this 4? Would it have been a wise thing to do according to you? The answer is no, because if you would have popped this 4 because of this, then you would not have been able to pop this 7 because of this 3. Do you understand this point? Yes or no? And the reason behind this is very simple, because even if you do not pop this 4, you will get a result starting from 4. And even if you pop it because of this, you will get a result starting from 4. And you can't say for sure that which one is going to be larger and which one is going to be smaller. So if you're not sure, then why you are popping? You pop only when you are sure that your next result is going to be smaller than what you would have had if you would not have popped. Is that making sense, that why this should be strictly smaller than sign and not smaller than equal to? Very important to understand. Yes or no? Right? Okay. Very good. So what do you believe? I think now the question is done. You can just go ahead and code it out. How many of you think that there can be some corner cases or some special cases that we have to handle while writing the code? If yes, then what are those corner cases? Can k be greater than n? Think. K cannot be greater than n, right? That is mentioned in the question itself. Okay. Yeah. Venkatesh is saying if k is 10, then okay. We'll consider cases like that. Let us take a look. Okay. So guys, just think and tell me one thing. When we have executed our stack-based logic, is it necessary that we would have performed all the k removals? Is it necessary? Just pause and think. Not necessary, right? In fact, we can take a very easy example over here. So let's say you have been given a number num, which looks like 1, 2, 5, 6, 7, 9, and k is equals to 3. Tell me, if you use stack-based logic, will you pop any item? Will you pop any item from the stack in your stack-based logic? The answer is no. Why? Because all these things are coming in a monotonic way. Because they are coming in a monotonic way, if you take a stack and first push 1 inside it, and let's say now you start from here, you'll see that, hey, this is greater. This is greater, so it can't pop it. So just push it. Similarly, when you come here, you will realize that this is greater than 2. That way, you will end up pushing everything in your stack and you have not performed any removal, right? So what can I say in this scenario, guys? Can I say that my stack would definitely contain items in a monotonic way from bottom to top? Because that is how my algorithm is being written, that it stores things from bottom to top in this manner. Now go back to a very basic example that I had taken at the beginning of the class. When you have something in which digits are sorted, and if you want to remove k items, where from do you remove those k items? You remove those k items from the end, right? And those k items would be the top k items. So at the end of executing my core logic, what I'll do is I'll run one more iteration of while loop, and there I'll keep on popping from the stack as long as k does not become 0. So I'll pop 3 times and that way I'll get a result of 125. So this is one case that many people forget. Is that making sense? Yes or no? Okay, let's talk about another case. Think if k was 6 in this case, then what would have been your answer? 0, right? Because you can just go ahead and remove everything. Now, when you look at it from coding point of view, at the end you would have a stack like this, and if let's say k removals are allowed, so you would pop everything and your stack would become empty. Now, when your stack becomes empty, this is needed to be handled in a separate manner. So you should mention it in your code that if your stack has become empty, that means you should return 0. So this is also to be handled. Is that making sense, guys? Yes or no? Right? Okay, great. Now, we all know that for normal cases, all that we have to do is, if let's say there was a number and stack and k finally became 0, we performed all the removals and data is present in this manner, then my answer is going to be 379. So I want to create a string which is concatenated with 3 and 7 and 9. So basically concatenated from bottom to top. So maybe in order to do this in a better manner, I can keep another stack and I can just pour this item over there. So if I do it, I'll get this. And then I'll take a string which initially is empty. And then I can keep on concatenating 3, then 7, then 9 to it. That's how I'll get my answer. Okay, cool. By the way, there is one more thing that I want you guys to keep in your mind. Let's take an example. If my number is 10032 and k is 1, yeah, can somebody tell me what is the answer over here? I'm going to cover every test case, okay? So just hold on for a while. What is going to be the answer over here? 32 is going to be the answer, right? And which digit have you removed? You have removed 1, and it makes absolute sense to remove 1, right? Because if I just remove this 1, I'll get 32. But when you print your output, would you want to print this or would you want to print this, 1 or 2? What? You'd want to print second thing, because leading zeros are not allowed. It was mentioned here that the answer must not contain leading zeros. Now, think of it from programming perspective. When you solve it, first you push this 1, and then you get this 0, which is smaller than the top of the stack, so you push this 0. And now you have utilized 1 removal, so everything else will be pushed as it is. And now, when you empty this thing in another stack, which will now contain things in the right order. And when you create this string, would you want to concatenate these zeros to it? Would you want to do that? The answer is no. So you need to have a logic that first removes these leading zeros. So once you have reverted this stack into another stack, you have to write a piece of logic that first removes the leading zeros. As long as it gets zeros, removes them, and then whatever remains is concatenated in the form of a string. Now, one thing is to be kept in mind. Sometimes it can happen that if your input was this, in that case, your expected output would have been 0, right? And when you code it, so if this is your actual stack, it would have contained these things, right? And when you empty it in another stack, it would have contained all zeros. And if you write a logic to remove all zeros, this stack would also have got empty. So this is also to be handled in a separate way. If you see that this thing has become empty, you would return 0, writing a separate condition. Does that make sense? How many of you understood the different logics, the different conditions behind that?